Hello and welcome to the World War Lab channel. Today we're diving into a moment from World War II that shows how technology, unseen and often overlooked, could shape the outcome of entire battles in ways few soldiers truly understood at the time. On February 20th, 1943, north of the Kasserine Pass in Tunisia, the official battle reports would never fully capture what the German tank commanders witnessed that morning. They observed American Sherman tanks carrying out maneuvers that went against everything Wehrmacht doctrine claimed was possible without visual signaling. Through the thick dust and rolling smoke of the North African battlefield, 5 Sherman tanks, separated by shattered terrain and with no direct line of sight between them, converged on German positions with timing that seemed almost supernatural. There were no signal flags waving, no flares lighting the sky, and no dispatch riders racing between vehicles. Yet they moved like a single living organism, each tank covering blind spots the others could not see, every crew knowing precisely where their comrades were positioned at any given moment. Inside German Panzer IVs equipped with FUG-5 radios, commanders struggled just to hear their own company leaders. Static overwhelmed their amplitude modulation systems, drowning out voices and turning vital commands into unintelligible noise. The 10-watt German transmitters, considered state-of-the-art by the standards of the 1930s, could rarely reach beyond a few hundred meters when tanks were in motion. To make matters worse, most German tanks carried only receivers. They could listen, but they could not speak. They were unable to report what they saw, unable to call for support, and unable to warn others of danger. The Americans, by contrast, were operating with a level of technology the Germans did not even realize existed. Every single tank was equipped with frequency modulation radios, built with crystal control precision, delivering 25 watts of transmission power and providing clarity that cut through engine noise and battlefield chaos like a knife through paper. Nearly 8,000 kilometers from Detroit's assembly lines, what would become one of the most decisive technological advantages of World War II was revealing itself. This advantage was not found in thicker armor or larger gun calibers, but in the invisible electromagnetic waves that connected every American tank crew in ways the Wehrmacht had never imagined possible. This transformation had begun on July 22, 1941, when the United States Army standardized the Signal Corps radio sets SCR-508, SCR-528, and SCR-538 for all medium tanks. While German forces were advancing deep into the Soviet Union, using tactics that relied heavily on radio communication between command vehicles, American engineers at the Galvin Manufacturing Company, later known as Motorola, were perfecting frequency modulation technology that would eventually make German systems obsolete. The engineering team included Daniel E. Noble, who envisioned how FM technology could be applied in military vehicles, and Henryk Magnowski, the principal RF engineer who solved the immense technical challenges of installing such sophisticated electronics inside the brutal, cramped, and violent environment of a tank. Their creation weighed 181 pounds and transformed every Sherman tank into a node in what was essentially the world's first battlefield communication network. The BC 604 transmitter generated 25 watt of power, 2.5 times the output of the German FUG-5 system. Operating within the 20.0 to 27.9 megahertz frequency range, it offered 10 preset channels with crystal control stability. The paired BC 603 receivers in the SCR-508 allowed commanders to monitor multiple frequencies at the same time, a capability that would prove decisive in combat. This meant American tank commanders could listen to higher-level command traffic while simultaneously coordinating with nearby units, something German crews could only dream of. The true revolution, however, lay in frequency modulation itself. Edwin Armstrong's FM technology, licensed for military use, eliminated the static and interference that plagued amplitude modulation systems. Where German tank radios picked up every electrical discharge and engine spark as noise, American FM radios delivered clear voice communication, even in the middle of artillery barges. Voices came through sharp and intelligible, even as shells exploded and engines roared around them. On November 8, 1942, Operation Torch brought American armor to North Africa. The tanks of the 2nd Armored Division landed near Safi and Fadala, equipped with SCR-508 radios that would soon prove their overwhelming superiority over German communication systems. The Afrika Korps, despite being the Wehrmacht's most experienced and battle-hardened armored force, operated under severe communication limitations that had become increasingly obvious. A standard German tank platoon consisted of 5 vehicles, but usually only 1 or 2 of them were equipped with full FUG-5 transceivers capable of both transmitting and receiving. The remaining tanks carried only FUG-2 receivers. These crews could hear orders, but they could not respond, and they could not report enemy positions or battlefield developments. German tank platoons functioned through a rigid hierarchy. The platoon leader transmitted orders, and subordinate tanks acknowledged those orders through their movements and actions rather than through spoken confirmation. When command tanks were destroyed, easily identifiable by their multiple antennas, entire platoons often lost coordination almost instantly. This vulnerability would prove catastrophic when facing American forces, where every tank was capable of assuming command functions if necessary. The Battle of Kasserine Pass, fought from February 14th to February 24th, 1943, provided a first major demonstration of American radio superiority. Although the battle was tactically a German victory, it revealed capabilities that stunned Wehrmacht observers. During chaotic and confused fighting, scattered elements of the U.S. 1st Armored Division managed to maintain coordination across nearly 50 miles of battlefield. Tank crews who had never met before were able to coordinate attacks, issue warnings, and react to changing conditions with a speed and precision that seemed impossible under such circumstances. They warned each other about emerging threats and called for artillery support through crystal-clear FM communications. German signals intelligence units intercepted these transmissions and were stunned by the exceptional clarity and coordination they recorded. The intelligence section of the 10th Panzer Division reported that American units were maintaining reliable communication at distances where German radios produced nothing but static. Even more disturbing was the realization that every American tank seemed capable of full transmission, not just designated command vehicles. The German FUG-5 radios, operating on amplitude modulation in the 27.0 to 33.3 MHz range, suffered from fundamental technical limitations. There are 10 what transmitters struggled to reach even 2 to 3 kilometers under ideal conditions, and that range collapsed only a few hundred meters once vehicles began moving. Every spark plug firing, every electric motor starting, every movement of the tracks generated interference that AM systems simply could not filter out. What should have been communication became a storm of noise. In September 1943, American armor entered Italy, where the mountainous terrain should have erased any radio advantage. Instead, FM technology became even more valuable in conditions that rendered German AM radios almost useless. The SCR-508's frequency modulation handled the multi-path interference of narrow valleys and steep ridgelines far better than amplitude modulation ever could. American tanks coordinated movements through terrain where visual signals were impossible, and German radios failed completely during the advance toward Cassino. American armored units demonstrated capabilities that defied German understanding. Tank platoons separated by ridgelines coordinated attacks with precision that German doctrine insisted required direct visual contact. After-action reports from the 1st Armored Division described routine coordination at distances where German radios produced only static and confusion. June 6, 1944 brought a new test. As Sherman tanks rolled off landing craft in Normandy, their SCR-508 radios maintained contact with naval fire support, a level of coordination completely impossible with German technology. But the brutal fighting in the hedgerows revealed a critical gap. Tank radios could not communicate directly with infantry radios because they operated on different frequency ranges. Infantry units used the SCR-300, which worked between 40.0 and 48.0 MHz, while tank radios operated between 20.0 and 27.9 megahertz. This communication gap proved deadly in the bocage. German infantry armed with Panzerfaust could slip close to American tanks, while nearby American infantry had no direct way to warn the crews. American innovation solved the problem within weeks. Tank crews mounted E-8 field telephones inside ammunition boxes welded to the exterior of the tank and wired them directly into the internal communication system. Infantry can now plug in and speak straight to the crew inside. By Operation Cobra in late July, this simple modification had revolutionized tank infantry cooperation. From July 25th to 30th, 1944, Operation Cobra demonstrated the full potential of American radio superiority. The 2nd Armored Division, commanded by Major General Edward H. Brooks, coordinated over 200 Sherman tanks through radio networks that enabled unprecedented battlefield control. German defenders from the Panzer Division faced an enemy that seemed to possess supernatural awareness. American tanks reacted instantly to threats reported by other units miles away. Artillery strikes coordinated through tank radios arrived within minutes of target identification. The contrast with German capabilities was brutal. Panzer, once Germany's premier armored division, had been reduced to communication poverty. Most of its tanks operated without radios at all, depending on visual signals in terrain where visibility rarely exceeded 100 meters. The few functioning radios suffered from interference and limited range that prevented any effective coordination. The irony was profound. Germany had pioneered the use of radios in armored warfare. Heinz Guderian, the architect of Blitzkrieg, had insisted on radio equipment in tanks as early as the 1920s. His book Achtung Panzer, published in 1937, emphasized communication as essential to armored operations. Guderian had built his entire doctrine around the idea that rapid armored advances depended on reliable communication. Yet by 1943, German tank production could no longer supply the radios his own doctrine demanded. German production statistics revealed the scale of the crisis. In 1943, Germany manufactured approximately 5,700 medium tanks, but produced fewer than 2,000 FUG transceivers. Many of those radios were reserved for command vehicles and assault guns, leaving ordinary tank units desperately short of communication equipment. Soviet tank forces suffered from even greater communication poverty. The T-34, despite being the most produced Allied tank of the war, typically entered combat without any radio equipment at all. Soviet doctrine relied on flag signals and pre-battle planning, a system that produced catastrophic results against German forces in 1941. By 1943, Lend-Lease aid began to provide some relief. American radios, including the SCR-508, sets equipped Soviet command tanks. But even by the end of the war, only about 25% of Soviet tanks carried any radios at all. The comparison made America's achievement unmistakable. While the Soviet Union struggled to equip even a quarter of its armored force with basic radio communication, the United States achieved 100% deployment of advanced FM systems in its tanks. Motorola's factory in Chicago became a symbol of American industrial mobilization at its peak. Before the war, the company produced car radios. Transitioning to military production demanded complete retooling and the solution of technical problems no one had faced before. Every SCR-508 required 2,748 individual components, all manufactured to exacting standards. The BC-604 transmitter alone contained 474 capacitors and 385 resistors. Crystal oscillators had to maintain precise frequency stability despite extreme temperature changes, violent vibration, and constant shock from combat. Production numbers told the story of American industrial power. In 1942, 3,800 radios from the SCR-508 family were produced. In 1943, that number jumped to 11,400 units. In 1944, production reached 24,000 units. Total wartime production exceeded 50,000 tank radio sets. This industrial miracle ensured that all 49,324 Sherman tanks manufactured during the war were equipped with sophisticated radio systems, an achievement no other nation even came close to matching. The advantages of the SCR-508 went far beyond frequency modulation. Crystal-controlled frequency stability allowed tanks to preset channels before battle and remain perfectly aligned despite harsh combat conditions. German FUG-5 radios, which relied on variable capacitor tuning, constantly drifted off frequency, forcing crews to retune in the middle of combat. The dual receiver configuration of the SCR-508 allowed commanders to monitor both their platoon network and their company command network at the same time. Orders flowed instantly down the chain of command while commanders retained continuous awareness of what their subordinate units were experiencing. The BC-606 intercom system integrated seamlessly with the radio, allowing every crew member to alert the commander to threats. Throat microphones and noise-canceling headphones made communication possible even in the deafening chaos of battle. Many German tanks lacked any internal intercom at all, forcing crews to rely on physical taps, gestures, or shouting to communicate inside a steel box filled with engine noise and gunfire. Power management gave Americans another decisive advantage. The SCR-508 could operate on either 12 or 24 volts, automatically adjusting to whatever power was available. Its dynamotor power supply produced stable, filtered electricity that eliminated interference. German radios, powered directly from vehicle electrical systems, picked up every spark and fluctuation as static, turning communication into noise whenever engines were running or equipment was in motion. The tactical impact of universal radio deployment reshaped American armored doctrine. The entire combat command structure, built around flexible task forces organized for specific missions, depended completely on reliable communication. American commanders could create ad hoc battle groups drawn from different units, confident that coordination would be seamless because all tanks shared compatible radios. This flexibility baffled German commanders, who were accustomed to rigid organizational structures forced upon them by limited communication capabilities. During the Battle of Ericourt in September 1944, the 4th Armored Division faced multiple German panzer brigades equipped with superior Panther tanks. On paper, the Germans had the advantage in armor protection and firepower. In reality, American radio coordination proved decisive. Every Sherman tank could report enemy positions instantly. Tank destroyers received targeting information from tanks they could not see. Artillery observers riding in Sherman command tanks called in devastating barrages within minutes. Over 3 weeks of fighting, the 4th Armor destroyed 281 German armor vehicles, while losing only 41 Shermans, a 7-to-1 kill ratio that completely defied technical expectations. Throughout the war, German intelligence failed to grasp the true significance of American communication superiority. Combat reports often mention American coordination, but attributed it to training rather than technology. A captured intelligence assessment from September 1944 stated, "American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures." The report completely missed the underlying technological advantage. German tactics never adapted to American capabilities. They continued targeting what they believed were command tanks based on antenna configurations, unaware that every Sherman could coordinate battlefield responses. They planned ambushes under the assumption that American tanks would lose cohesion once separated, not realizing that constant radio contact preserved unit coordination regardless of visual contact. They were fighting an enemy whose command structure was invisible to them. March 1945 marked the peak of American communication superiority. As U.S. forces approached the Rhine, their command and control capabilities reached unmatched levels of speed and coordination. The capture of the Remagen Bridge became a dramatic demonstration of this advantage. When the 9th Armored Division discovered the Ludendorff Bridge still standing, radio reports, reached First Army headquarters within minutes. Within an hour, divisions across the entire front were already shifting their movements to exploit the sudden opportunity. German forces, dependent on fixed telephone lines that American aircraft systematically destroyed, could not respond with anything close to that speed. American radio coordination created an almost impenetrable defense of the bridgehead. Tank platoons from different battalions integrated seamlessly, coordinating their fires through shared radio networks. German counterattacks, crippled by communication failures, arrived in scattered fragments and were destroyed one by one. Lacking synchronization and reliable command, their assaults collapsed before they could gain momentum. By April 1945, the encirclement of the Ruhr Pocket demonstrated the final culmination of American communication superiority. American armored columns from the 1st and 9th Armies coordinated a complex double envelopment entirely through radio communication. Inside the pocket, more than 325,000 German troops found themselves trapped, in large part because their communication systems had collapsed. American fighter bombers, guided by forward air controllers equipped with radios, systematically destroyed German communication nodes. Wehrmacht units lost contact with higher headquarters and with each other. Field Marshal Walter Model's final messages before communications failed revealed the depth of the crisis. There was no contact with adjacent units, no communication with higher headquarters. Fighting continued, but coordination had become impossible. American radio superiority profoundly changed the psychological experience of tank warfare. American crews fought knowing they were never truly alone. Even when physically isolated, they remained connected through invisible radio waves. German tank crews experienced the opposite reality, a sense of deep isolation. Unable to communicate, they fought individual battles within a much larger conflict. Otto Carius, one of Germany's most successful tank commanders, wrote in his memoir Tigers in the Mud about the difficulties of combat, though he focused more on tactical challenges than on the communication gap itself. The strategic implications went far beyond individual engagements. American advances in 1944 and 1945 maintained their tempo in part because of radio coordination that German forces simply could not match. The Third Army's rapid race across France depended on radio networks that maintained command and control over hundreds of miles. German commanders consistently underestimated American capabilities because they could not even imagine the level of communication superiority the Americans possessed. Heinz Guderian, in his role as Inspector General of Armored Troops, recognized the problem but was powerless to solve it. In a memorandum written in December 1944, he acknowledged that American coordination effectively negated German advantages in tank quality and firepower. After Germany's surrender, American technical intelligence teams examined captured German equipment. Their findings confirmed what combat experience had already shown. German tanks often possessed excellent armor and formidable weapons, but their communication systems were catastrophically inferior. U.S. Army Technical Intelligence Report Number 176 concluded that German tank communication equipment was approximately 5 years behind American systems. The absence of frequency modulation, the limited distribution of radios, and poor electrical suppression created critical and unavoidable vulnerabilities. Soviet evaluators reached similar conclusions. When the Red Army gained access to captured German equipment, they chose to copy American radio designs rather than German systems for their post-war development programs. Production and deployment statistics revealed the true scale of American achievement. For the SCR-508, SCR-528, and SCR-538 family of radios, total production exceeded 50,000 units. Sherman tank production totaled 49,324 vehicles. The radio deployment rate was effectively 100%. Transmission power was 25 watts. Frequency stability was crystal controlled to within plus or minus 0.01%. Operational range while moving was about 7 miles, and when stationary, between 10 and 15 miles. German production told a very different story. Approximately 6,000 FUG-5 transceivers were manufactured. Meanwhile, about 12,000 medium and heavy tanks were produced. The full transceiver deployment rate was only about 20%. Transmission power was limited to 10 watts. Frequency stability varied by plus or minus 1%. Effective range while moving was only half a mile to 1 mile, and when stationary, roughly 2 to 3 miles. The difference in battlefield effectiveness was just as dramatic. The average time for an American artillery fire mission was 3 to 5 minutes. For German units, it was 15 to 30 minutes. American tanks achieved near total coordination across their formations. German tanks with full communication capability made up only about 20% of their force. The radio superiority of the Sherman tank established principles that still govern armored warfare today. Modern main battle tanks carry advanced communication suites that trace their lineage directly back to the SCR-508. They are digital rather than analog, but they remain built on the same foundational ideas: universal deployment, constant connectivity, and reliable coordination across the battlefield. The German Bundeswehr, rebuilt in the 1950s, made communications a top priority based directly on the lessons learned from World War II. Every Leopard tank produced afterward was equipped with comprehensive radio systems. One Bundeswehr training manual stated it clearly: the defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority. It was an admission that raw firepower and armor meant little without the ability to share information and coordinate action. Modern conflicts have repeatedly confirmed this lesson. In the 1991 Gulf War, coalition forces with superior communications destroyed Iraqi units that operated Soviet-designed tanks, which were often individually stronger on paper, but equipped with inferior radio systems. In 2003, American forces again demonstrated that network-centric warfare could defeat platform-centric warfare. The story of American radio superiority in Sherman tanks was not just a historical curiosity. It was an early victory in the electromagnetic spectrum, more decisive than any advantage in armor thickness or gun caliber. German tank crews fought much of their war partially blind to this revolution. They discovered too late that every Sherman tank was not merely a fighting vehicle, but a node in what had become history's first true battlefield network. The SCR-508 radio transformed the M4 Sherman from a merely adequate medium tank into one element of a vast weapon system that included every other American tank on the battlefield. That transformation proved more decisive than any improvement in armor or firepower could ever have achieved. Every Sherman carried the tools of victory not only in its 75mm gun or its sloped armor, but in the 181 pounds of radio equipment that connected its crew to all other American tank crews. That connection created a form of collective intelligence that no individual German tank, no matter how superior its armor or weaponry, could ever match. German forces learned this through bitter experience. At Kasserine Pass, in the mountains of Italy, across the hedgerows of France, and in the final battles inside Germany, American tanks demonstrated levels of coordination that German doctrine insisted were impossible without direct visual contact. The Wehrmacht never developed an effective counter because it never fully understood the technological gap it faced. Field Marshal Wilhelm Keitel's reported comment at Germany's surrender captured this truth, whether the quote was exact or apocryphal. "We knew how to build better tanks, but you knew how to make them work together." It expressed the core difference between the two approaches to armored warfare. America had not built just 49,324 Sherman tanks. It had built 49,324 interconnected nodes in the world's first armored battlefield network. What historians now call the revolution of network-centric warfare did not begin in the late 20th century. It began in 1942 when the first Sherman equipped with an SCR-508 radio entered combat. From that moment on, warfare was changed forever. The side with superior communications would defeat the side with superior weapons. The network would defeat the platform. The connected would overcome the isolated. This transformation occurred largely unseen by German forces. They observed American tactical effectiveness, but failed to recognize its technological foundation until it was far too late. By the time German commanders understood that every Sherman possessed communication capabilities that most German tanks lacked, the war was already effectively decided. The failure of the German military to recognize and adapt to American communication superiority stands as one of the great intelligence failures of World War II. Despite countless battlefield encounters that demonstrated American coordination advantages, German leadership never made solving their communication crisis a true priority. They continued to build technically superior tanks that fought as isolated individuals, while American forces built adequate tanks that fought as tightly coordinated teams. In the end, the electromagnetic waves carried by SCR-508 radios proved more powerful than the armor-piercing shells fired by German 88mm guns. The ability to coordinate, to share information instantly, and to fight as a unified force rather than as individual vehicles became the true deciding factor. This invisible advantage determined victory more reliably than any visible superiority in armor or armament. The radio superiority of the Sherman tank changed warfare forever. It established the principle that in modern combat, connection equals survival, and isolation equals defeat. German troops discovered this reality across battlefields on 3 continents, learning too late that the Americans possessed not only numerical superiority, but superiority in the dimension that mattered most: the ability to fight as one,